Hello Java class, welcome to Unit 8. We have two more units left, Unit 8 and Unit 9. However, none of these units we will actually have our end of unit tests on. So actually even in Unit 8, we will not do any labs. So I want you guys to just pay attention and grasp all the different concepts. And then when we step into Unit 9, we will do at least one lab before you all step into your final project. So Unit 8 sort of doesn't introduce you to anything very new. It just expresses again the fundamentals of object-oriented programming. Okay, so we'll breeze through this unit. So object-oriented, a gentle first exposure. Object-oriented programming is a style of programming that incorporates these three features. So we're going to look at these three features: encapsulation, polymorphism, and class interaction. So it says object-oriented programming simulates real life by using a programming style that treats a program as a group of objects. Okay, so just pay attention to these three keywords: encapsulation, polymorphism, and class interaction. So, well, this is again about object-oriented programming. It was one of the main reasons we now teach Java instead of C++. So C++ was designed to be backwardly compatible with the original non-object-oriented C programming. Therefore, C++ is not fundamentally an object-oriented programming language, but it could be used. But Java is an object-oriented programming language. Again, reiterating, an object-oriented programming example, a car could be an object in Java. Objects, again, have attributes and methods. Okay, so car, the attributes that would be associated with a car could be like the make, the model, color, number of doors, number of seats, and the methods are what? The verbs, right? Like the actions, the behaviors, like drive, park, reverse, tow. So be sure that we understand the distinction between what are attributes. They are things about the object, and verbs, they are things that the object can do. Encapsulation. So that's the first new word that we saw at the beginning of the unit, right? Encapsulation, what that means is when we package all the attributes and methods of an object in the same container, that is called encapsulation. Okay, so attributes, methods in one container, or that packaging is called encapsulation. All right, this is our next keyword, okay? Polymorphism. If we review our algebra, we should remember what is, I think they're just trying for you to get to understand what do they mean by polymorphism. So they are saying a monomial is one that is a single term like 3x, binomial, 3x plus 7. A polynomial is basically many terms, x squared plus 3x plus 7. So poly means many. Polymorphism means many forms. Polymorphism is an advanced concept in computer science, which will be discussed more in AP Computer Science. So, won't be in this class, but if you take AP CSA, you'll understand this somewhere. Class interaction or inheritance. All right, so this is, again, very important. So pay attention to at least encapsulation and inheritance. So there are different types of class interactions. One type of class interaction is inheritance. So inheritance is a type of class interaction. Suppose you wish to create truck objects, limo objects, and race car objects. Instead of starting each of them from scratch, we can use the existing car in the following manner. Okay, a truck is a car with four-wheel drive, big tires, and a bed. A limo is a very long luxury car with many seats. A race car is a car with one seat, a very powerful engine, and a number painted on the side. So what they're trying to get you to understand is, so say you were to suppose write a class, okay, for a truck, write a class for a limo, write a class for a race car. Instead of building three independent separate classes, which are not linked to each other, you could in fact build one main class and then inherit the properties of that main class for the truck and make some changes, inherit the properties of that main class of car to the limo and make some special changes for the limo, and inherit the properties of car for a race car and then make some special changes and adapt it to a race car. So they're trying to help you to understand that you can potentially save the work that you do and then extend it to different kinds, like the truck, the limo, and the race car. Okay, you'll understand this some more as we talk about it. So object-oriented programming and reliability. Okay, 4 stages of program design: cryptic programming stage, unstructured spaghetti programming stage, structured programming stage, and object-oriented programming stage. The object-oriented programming stage is the most developed that we use right now. So avoid spaghetti programming, okay? What spaghetti programming is typically what this flowchart is showing you. You have a program statement to a program statement to a program statement, program statement, program. So everything is basically all over the place. Back to encapsulation. So Java encapsulate data and action modules that accesses the data in one container called an object. So data and actions. So Java does this breakdown, right? Data and actions encapsulates all of them into one container called an object. Object members that perform some task are called as methods, and object members that store data are called attributes. Okay, again highlighting encapsulation. The airport analogy. So in a normal airport, the following places are scattered all over the airport: curbside check-in, security, departure gates, arrival gates, baggage claim. The same gates are used for arrival and departure of different people to different places. So this is like a non-object oriented airport. Okay. Everything is all over, very disconnected. An object-oriented, an OOP-fied airport, like how would an airport be object-oriented? An airport would never be designed this way, but if they followed the encapsulation concept of object-oriented programming, you would have the following destination: class destination, and the object, class destination, okay, the object of that an object of destination is like Paris. Class destination, an object is like Amsterdam, okay? The methods that you could have will be check-in, security, gates. The methods that you can have is check-in, security, gates. Do we see how the things are sort of packaged? The objects are Paris and Amsterdam, and the object have certain methods associated with, and overall the class is destination. The bank class from scratch. Okay, now they're trying to get, you guys have already seen this bank class before, but now they're trying to show you how did they write this bank class. Okay, so, well, again, this is our public class, that's Java, and this is our main file, right? And then we have class bank, which here is completely empty. Okay, so this is in the same Java file, and it's empty. Then we move on. What do they do now? Here they make an object of this bank class, okay? But nothing is happening in the bank class, so it is not going to do anything. All right. Now here they say this program may seem logical. Values are assigned to program variables. The data variables are inside the Tom class container. Okay, so let's just read what's happening. So in this main file, it looks like they declared an object Tom. Then they do tom.checkingBalance equals 1000, tom.savingsBalance equals 3000, and then they're doing system.out.println, tom.checkingBalance, tom.savingBalance. They're trying to access these two variables. Okay, and ta-da, you get an output. Okay, this way of programming is written. Nothing prevents Tom from changing his balances to 1 million or more. Nothing prevents someone else from changing it to 0 as well. So do you guys see what are they trying to highlight here? So here in class, they declared two variables, checking balance and saving balance, okay? And here's your main program. Here, in order to access these variables, which are in another class, you need to do tom.checkingBalance. And you modified it, right? tom.savingBalance, and you modified it. And appears as though this modification can happen very easily and very randomly if you wish to. You can assign it to whatever you want to. Okay. All right. So now they're going to show you how this is not actually a good way of writing an object-oriented program. What you really need to do is these things which are called your attributes or your class member variables, they always need to be, so data attribute, they always need to be declared private. Okay, so when they're declared private, now when you try to do something like this, tom.checkingBalance equals 1000 and 3000, it's going to give you an error. It's not going to let you easily access these attributes, which are now private to this bank class, okay? Which is how it should be. Like, you wouldn't want anybody to easily get access to your checking and savings balance from your main program. Like, say, imagine you were giving this to somebody, right, to work with it. You wouldn't want them to easily modify these values. Private and public members. Members in a class need to be declared as private or public. Private members cannot be accessed by any program statements outside the class. Public members of a class can be accessed by program statements outside the class. Class attributes, so this is the key, you guys. Class attributes are usually declared private. Class methods are usually declared public. How does using private give you any security when you can just change it back to public? If this is a question that was lingering in your head, you guys, how does using private give you any security when you can just change it back to public? Okay, now they give you this analogy to understand that. Think of any video game that you have purchased. Do you ever see the source code? Only the programmers have the source code. What they sell to users is an executable file. Okay. Constructor methods. So here you have, this is that constructor method, which some of you guys may have already seen when you guys landed up making a new Java class file. It just popped up with this special method which has the same name as that of the class. What is a constructor method? So constructor method is automatically called when a new object is constructed. There is no output because data is assigned but not displayed. So here it looks like in void main, you have bank Tom, new bank, and here you do system.out.println. You did not really invoke any method from the bank class through Tom. All you just did was created the Tom object. But as soon as you created the Tom object, this constructor was automatically invoked. That means Tom.checkingBalance was assigned a 0 and Tom.savingsbalance was also assigned a 0 automatically. Okay. So couldn't we just create an initialize data method instead of using a constructor? You could, right? We could make a similar method like the constructor. It is possible that you would forget to call this initialize data method. A constructor is more reliable because you cannot forget to call a constructor. It is called automatically. That's the benefit of using a constructor. You could do this exact same thing in a user-defined method that you would create inside this class. But if you do that, then you have to be sure that you call that method. But this way, it's automatically called. So a constructor is basically used to give initial values to any of your data attributes that you have in your class. That's the purpose of this constructor. So instantiation and construction. A class is a template that can form many objects. An object is a single variable or an instance of a class. Objects are sometimes called instances. An object is created with the new operator. Creation of a new object is called instantiation of an object or construction of an object. A special method that is called during the instantiation of a new object is called constructor. This is something that you guys want to highlight in this unit because this is a little new. A special method that is called during the instantiation of a new object is the constructor. I'm going to pause here, you guys, and I'll pick this up in your next lecture.